Let's talk about what we discussed last time, because the whole basis of this argument, and remember, what does argument mean? Defending your position, giving reasons for your conclusion. That's really the technical definition. The argument then that we started off with was essentially this: God or not God. There's very few things that you can say is an irrefutable fact or an irrefutable proposition or an irrefutable statement. In fact is, no matter what you say, if you say, I believe in God, somebody can say, I don't believe in God. I believe that, that those pews exist. Somebody can say, I don't believe those pews exist. The fact is, almost everything that somebody simply asserts can be refuted by somebody else. But it's very difficult to refute the proposition there's either God or there's not God. So this is how we started. And then the second thing that we did, we said, okay, we're going to assume what then? Right. We are going to assume not God. Okay? Now, by assuming not God, what we're going to do then is essentially use a disjunctive syllogism to prove that God must exist. Okay? Now, the logical form again is A or B. And then what's the second premise? Not B. Therefore, A. Now, if it's true that there's either God or not God, and not God is false, there must be God. Your conclusion must be as true as your premises in a valid syllogism. And that is a valid syllogistic form. Okay? So we're going to assume not God. The third thing we did then, we said, if there is not God, then there's a few questions we'd like to ask. What are the questions? How did matter originate from nothing? Okay? It's a good place to start. Okay? The fact is, I don't care who these people are, don't care if they're, Stephen Hawkins or whoever, none of them can answer this question. And the purpose of their books, and they are intellectual books, is to try to give you a plausible adult fairy tale to show you that this can happen, even though it really seems to be impossible. And when you get done, if you want to believe it, there are people who, in a sense, are forced to believe it because of their own presuppositional mindsets. All right, but we're going to also give them matter. Now, if there is matter, and I'm using this hypothetically, then the next question that you should ask is what? How did life originate? Exactly. If matter, how did life originate? What are the plausible choices of life originating, assuming not God is true? What are the plausible answers for the origination of life, assuming that not God is true? That's not life. We've already assumed. We're going to go past Big Bang and say that matter exists, okay? Yeah. Now, if you go to Big Bang and say, how did matter originate? So, Big Bang, then you say, well, where did the matter of the Big Bang come from? You see, we're already past that. We're assuming that we're going to give you matter, okay? Which is obviously unanswerable. But now then, if you have matter, then how did life originate? What are the plausible answers for life originating? I don't know any other answer except chance. If you say it's by design, then you go back up here and it violates number 2. You have to assume a designer, else, therefore a God. So if matter exists, how did life originate? I only know one answer. Chance. Really, all you people have been educated, to some degree, and some of you very educated. Tell me another plausible answer if there is no God, other than just simply chance. If there's God, then of course, nothing happened by chance. It all happened by design. But if there is no God, then everything happened by chance. I don't know of any other answer. Then, the question is very simple. If by chance, then what? What are the probabilities? Exactly. And this is where it gets interesting. Very interesting. Does everybody understand how to, at least in an elementary fashion, compute probabilities of certain things? If I have an event, and that's what they're called, if I have an event, and I don't have a coin, if I have an event called tossing a coin, and I know that there are two sides, then would everybody agree that the probability of throwing a head or a tail is 1/2? Yes, it really could. We're going to assume that there's only two. You're absolutely right. It could stand on edge. Maybe that's the answer to the universe. It stood on edge. I didn't think about that. Exactly. It could stand on. We're going to say, though, that there's only two possibilities. Okay? We're going to have something so thin it can't stand on edge. But now that if I toss a coin and the probability is 1/2 that I get a certain event, either head or tail, then what's the probability that I get two heads in a row? 25%. Right. Because all you have to do really is take the event 1 times event 2, and what is the probability of throwing again, on event 2, what's the probability of throwing a head or tail? Still 1/2. But to get two of them, it is event 1 times event 2, therefore it is 1/4. Okay? So to get 3 heads in a row, it is 1/8, okay? 1/2. And then to do in a row, it is 1/2 to what? Nth power, right? This. Okay? Now that's meaningless, of course, because what does that mean? What does this exponent here mean? If I say 1/2 to the, let's take a simple one. Let's say I said toss a coin 5 times, and I say the probability is 1/2 into the 5th power. What does that mean? Right. So all it means is take this number here and multiply it by itself 5 times. That's all it means. Okay? Therefore, Paul, since you're in the computer business, 1/2 to the 5th power is 1 over what? 32. Right. 32-bit machine, right? So when they say, all these things and all these computers are built on binary system, really, okay? So a lot of them, are 2 to the 8. What is 2 to the, or actually 2 to the 16th power? What's 2 to the 16th power? What's 2 to the 8th? Well, it'd be 2 to the 4th times 2 to the 4th, right? 16 times 16, 256, right? And then 2 to the 16th, it'd be 256 times 256. To study probability requires a simple understanding. In order to understand probability theory, you almost always need to have an understanding of exponential functions. Exponent simply means taking whatever the base is times itself by the number of exponents here. So if I say then 10 to the 5th power, how can I write that out as a single number? What would that be? Right. It'd be 1 with 5 zeros. The bottom number is 10. What is any number? What is 1 to any power? Itself. Because 1, if I take 1 times itself 100 times, I still get 1. Okay? So if I take 10, let's just do it, 5 times, okay, I get 1, 2, 3, 4, 5 zeros, right? And the 1 should equal 1. So really, 10 to any power is simply a 1 with the number of zeros as the exponent. That's how easy it is. Okay? We're all in agreement. So if I say then 10 to the 100th power, what does that mean? 1 with 100 zeros. Right. 1 with 100 zeros. Right. 10 with 99 zeros. Right. Exactly. Same thing. Okay. But anyway, you got to end up with 100 zeros. Okay. All right. Now, let's talk about that number. I always remember when Jason started studying a little bit of math, we had discussions all the time, Jason, my son, about what does a large number equal. And by the way, 10 to the 100th is, what is that called actually? In Yahoo now, it's a Google. That's right. 10 to the 100th power. If you go to Yahoo now, they have what kind of search? Google search. That's where they get it, But this Google was named by a mathematician who essentially asked his child, we don't have a name for the goggle, Google. That may be a goggle. Let's go this way. How's that? Is that better? Google. Yeah, the spell checker. Thank you. I got my spell. Diane, you should have caught that. Diane's my spell checker. She is excellent. Yeah. So a Google then was named by a mathematician who asked his child, what would you like to name 10 to the 100th power? By the way, if you look up books in mathematics, you'll find that different countries will have different names for these large exponential functions. Like, what's 10 to the 64th power? I remember learning this in high school, just because I looked it up. Vegetarian. Yeah, vegetarian. I don't know why I remember it, but it's 10 to the 64th power. Okay, just like you have millions, billions, what? Trillions. What's after trillions? I think it's quadrillions. Yeah. And then you're going up, and I forget a lot of them. But I remember 10 to the 64th power was a vegetarian, and 10 to the 100th power is a Google. All right, so now then we've got these large. Tell me this. Give me something physically that represents a Google something. Like I said, okay, we've got a Google of these running around. Tell me something that would equal a Google. Now I've really tried this. I've read a number of people who have estimated the number of atoms in the universe, and the average that it comes out is 10 to the 75th power. Okay? Now, if you don't get a perspective of this, you really miss the essence of our proof when we get to the end of it. So this is very, very important. 10 to the 75th atoms, and let's assume they're right, because many people now feel like the universe is not infinite, but is in fact fixed, okay? It may be expanding, but it has a fixed number of atoms. Otherwise, you're creating atoms all the time. But according to Newton's law of physics, there's matter not being created or destroyed. You see? It just simply changes form. So if I have 10 to the 75th and somebody says, I don't like that because I believe, now let's see how good you are at this, I believe that there are 10 essentially parallel universes, therefore there's really 10 to the 75th power atoms in every universe, then how many, that's right, then how many atoms would I have? You're exactly right. It would be times 10 parallel universes, which is 10 to the first. And now let's think about it. What do I do when I multiply common bases together? What do I do with the exponents? You actually just add the exponents together, and so all you did was increase it by 1. Everybody see that? Because really, doesn't this have 75 zeros? How many zeros do I have here? 1. So 75 plus 1 is 76 zeros. Suppose somebody said, I think that there are 100 electrons per atom. Therefore, we're trying to get to the number of particles in the universe. I have 100 electrons. Now I've got 10 parallel universes, so 100 is 10 to the what? Second, and so it'd be what, Bob? 1078. So with 100 electrons, with 10 parallel universes, I'm still just 10 to the 78. Suppose you said, now by the way, what is the most common element in the entire universe by far? Huh? No. Hydrogen. How many electrons does hydrogen have? 1. So I'm telling you, tell me some things that have 100 electrons. Uranium and a few other things that are really heavy elements will have 100. Let's say that you thought, I think there's maybe stuff out there with 1 million, 1 million electrons. So let's get rid of that. What is 1 million as an exponent? 6. Therefore, how many elements would you have with 10 parallel universes? 10 to the 82nd. You're still not even close to one Google. Now, I'm trying to tell you, my son and I, Jason, we used to have this argument. He used to argue, well, Dad, I think that, we would have this many number of atoms or elements. So I said, doesn't even come close. You can't think of anything physically that even approaches this. And the only reason we're going to come to something that's far greater than this is because it deals with a mathematical probability. But in the physical world, those things really can't happen when they get to a certain probability. So, here we are, 10 to the 75th power atoms, 10 parallel universes, 1,000,000 electrons per every atom, and we're still just 10 to the 82nd power. And so now then we come down to a very simple thing. And the question is, how can I then, if it's by chance, what is the probability? What is that probability that life could exist by chance only? So we're going to start off then with the next major point. What are the basic building blocks of all life? Protein. Exactly. Now, what are proteins made of? Amino acids. And now then you have a very interesting problem in nature. It turns out that amino acids that are conducive to life must be built only with left-handed amino acids. But there's really an equal number of right-handed amino acids. But if I have a right-hand amino acid that is mixed with a left-hand amino acid, it can't build any proteins that are conducive for life. They don't live. Now, going back to what we did here, therefore, what is the probability that I get a single left-hand amino acid? 50%, 1/2. What is the chance that if I'm building now a protein, if I'm building a protein, so 1 is 1/2, and I'm building a protein, what is the probability that I have 2 left-hand amino acids without getting a right-hand amino acid mixed in with it? Okay, 1/4, right? Etc., right? Now the question is, how many amino acids do you have in a protein? You can have in the hundreds of amino acids. So now then, you have this huge number, okay, like 1/2, let's say, to the 200th power, okay, which, and I forget exactly what the average, actually, I think, I wrote down 400. I was reading, what is the average number? It could be as high as 400. Now, I don't know how many of you have gone through this little game or not. Years and years ago, remember, Alan, we read this about the guy who decided to bet, and I believe it was a king, and he says, here's this chessboard. He says, if I beat you in chess, then what I would like to do is get 1 penny for the first square, and then for every square after that, double it. And the king said, okay, Well, he beats the king, okay? The king of Persia, whatever it is, or, India, that's where chess came from. So how much money did he get then if he started off with a penny on the first square? How many squares are there in chess? 64, same as checkers. So you'd have essentially like 2 to the 63rd power, actually, because the first one doesn't count, it's not a 2. So how much money would you have? More money than there's ever existed in the entire history of the world. You see? It's a huge number. So if you go to 1/2 to the 400th power, this actually comes out to be, and I wrote down this, you can just use your calculator and figure it out. This comes out to be, I believe, the probability is 1/10 to the 114th power that this could happen. Now, I want you to look at this again. We said a while ago that if I had an estimated 10 to the 75th power atoms in the universe, I had 10 parallel universes so that, we could take care of the possibility of that. And I said, let's have 1,000,000 electrons per, atom. I'm only at 10 to the 82nd power. The probability of getting 1 protein is 1/10 to the 114th power. This number is so huge that there's nothing physically that I can tell you that would be equivalent to it. There's nothing even close. Not even close. Now, what I'm telling you is this is the part. How many of you heard this in your science courses when you were being taught evolution? Did you hear that in your science course? Did anybody ever say, sounds to me like there may be a problem with probability of getting for evolution to be true? Did you ever hear that? I never heard it. Nobody ever said it. And yet, these probabilities, by the way, you will find a few people who are honest enough to say, we understand this probability, but we still believe evolution's true. Now, here's the question. When Huxley debated Wilberforce, Dr. Wilberforce, back in the late 1800s. Huxley was a dyed-in-the-war Darwinian evolutionist. Wilberforce was a Christian scientist. And Huxley supposedly won the argument, even though essentially, and Wilberforce didn't say this, but he's pretty close to that. He was saying, hey, look at these probabilities here. But he still won the argument. How could he have won the argument? How could Huxley have won the argument even though his opponent knew some of these probabilities? Exactly. With infinite amount of time, what probabilities become certainty? Which probabilities become certainty? All of them. And this is where he won. And he sat back there and said, with infinite time, I can have 6 monkeys. You remember the story? 6 monkeys do what? Type up the complete works of William Shakespeare. Well, it sounds like a good argument, doesn't it? Now, you better write this one down because you're going to hear this. They're going to tell you this. What's the problem with that argument? Because now it's very simple. That's not it, though. That's right. If there's an infinite amount of time, we went over this last week, then what must be true? We must be at a state of what? Absolute zero, because with every physical and chemical reaction, there's a loss of what? Energy. And with infinite, if you have this infinite time to get this probability where it becomes a certainty, then with that you have all these chemical and physical reactions, and all energy would essentially be gone, used, and you'd be at absolute zero. Therefore, all scientists understand this. There must have been a start of matter. It could not have existed for eternity. Now, what is generally the most accepted length, time of the universe? Yeah, 10 billion, exactly. Most people say it cannot exceed 10 billion. And there's lots of reasons for it, and most of them have to do with essentially the relationship of all the galaxies, planets, and all this kind of stuff. Now, how much is 10 billion as an exponent? 8? Million is what? 6? No, 6, 7, 8, 9, 10. Should be 10. 10 to the 10th. You got to count on myself. 10 to the 10th. A billion, 10, so we're talking about 10 billion. A million is 6, right? Yeah, 10 billion is 10 to the 10th. Okay? Well, look. This is practically nothing compared to this. Now, if you've gone through infinite math is calculus. Okay? Infinite math says things like this. If I have 1 over x, okay, as x approaches infinity, what happens to the value of 1 over x? Nope. 0. Exactly. It equals 0. Essentially, when we look at the age of the universe and we look at, you see, the number of atoms in the universe and compare it to the probabilities, these are so different in quantity that essentially it goes just like calculus does. It essentially goes to 0. And fact is, there are people who say this. And if you want to write this down, I don't know if I put it in our notes or not. Anything over 10 to the 50th power is considered to be impossible. I just got through reading this the other day by some secular mathematician, and he used exactly the same number. He said anything over 1 over 10 to the 50th power is mathematically impossible. By anybody's standard, can't happen. We can imagine what kind of number is this? 50 zeros out there. But look what we're talking about to get. Now let's think about this. 1 amino acid of a protein. Amino acids don't even live. Now, then you take this another step. If it takes this probability to get 1 amino acid, how much does it take? What's the probability to get 2 amino acids? Because we said this a while ago, for every event that you have, if you have a second event of the same probability, what do you do with the probabilities? You times it, right? So what is 1 over 10 to the 114th times 1 over 10 to the 114th? 10 to the 28. That's right, 1 over 10 to the 228. What is then the probability of getting a living, self-replicating cell by chance only? Quick, Diane. That was the right answer. None. It is so, in fact, now think about this. This is the thing you have to realize when you start dealing with probabilities. A lot of people say, well, look at all this stuff out there. You know, some of these evolutionist books that I've read says, by the very fact that you have trees and animals, etc. out there, show that evolution happened. What kind of argument is that? It's a stupid argument. That's what it is. It's a dumb bunny argument which they don't really want to discuss it. They'll just sit there and make some sort of declaration like that, and it is absolutely ridiculous. The stupid Christians. Yeah, well, there's lots of stupid Christians too. Yeah. Well, yeah, we're going to get. I think we've already touched on that, but we'll touch on that again. Now, the fact is, let's take something like this. I'm going to make something very simple. How many of you believe that this could have been actually dug out of some, formation, and the aggregation of matter and the printing and all this happened to assume this form by chance only? Now, this is pretty simple, isn't it? What happens if we don't have a computer here? Bob's built me a supercomputer now, linked to my other supercomputer as soon as I get the chip. What is the probability that I could actually go out into my backyard and dig up a 1.3 gigahertz processing computer with a DVD and a read-write ROM? What's the probability of that? Now, the fact is, we know that that'll never happen, don't we? Reasonable people will tell you that can't happen. But somebody did build that computer, didn't they? Somebody built the hardware, and Bob put it together for me, and it works. Let me ask you this. If I took all the scientists of the world and said, just build one simple self-replicating cell, how long do you think it'd take them to do it? They can't do it. And that's by design. What makes you think then that it simply could happen by chance only? In other words, if you take coins, remember if you have some coins, this is an important point because this is the difference between design, you see, and probability. I need several to illustrate this. Beam is always loaded. Where do you get all that money? Thank you. It's the only way I can. That's fine. Okay. Okay. Suppose I said I've got five coins here, and I, shook them all up, and I threw the coins out. What is the probability that all of them would come up heads? We just talked about that. Excellent. Now, have you all ever played Yahtzee? Where you have double sixes, right? Or we have sixes. How many? You have six, 5 sixes. What's the probability of throwing all sixes?
Every 32 times 6.
Depending on if you cheat or not, right? No.
32 times 6.
Well, you'd have 6 dice, right? No, 5 dice. With 6 sides, so it'd be 6 to the 5th power. Okay? So it'd be 36 times 36 times 6. Okay? Now, how often have you really thrown 5 sixes playing Yahtzee? A few, right? It has happened, right? I'm not saying it doesn't. But what if I said, why don't you just take those 6 die and just simply place the 6s up on each one of them? Now, I'm just saying, what's the probability that you could do that? 100%, exactly. Now, this is what I'm trying. Yeah, okay, some people, hey, in this day and time, better not say, for you, yes. For other people. Now, this is the thing that we have to realize. People will sit there and you read your science books and they'll call a cell, a self-replicating cell, a simple cell. But all the scientists in the world, combined with all the knowledge they have, even though they're able to build all these computers, can't build one single self-replicating cell by design. Again, but they're willing for you to believe that all of this biological stuff that happens in your body happened by what? Chance. Now here's the thing. So here we have these amino acids, and we haven't even got to the next step, which is really now I've got amino acids, and now then I want to get a protein. How many amino acids, again, make up I've got one protein, which is this. How many protein make up a cell? Right, but how many proteins are in an amoeba? See, there could be many proteins, right? By the way, does an amoeba have not only some proteins, but does it have some molecules like a DNA and RNA molecule and nucleus? What's the probability of getting a DNA molecule, an RNA molecule? Large. Right. Google, no. This is Google's become almost nothing compared. Now let's say that we have, let's say that we have 1 over, 10 to the, and I'm not exaggerating here, 10,000 power. That means 1 with 10,000 zero, forget one cell. There are people who try to compute this and you really get lost in the computation so large. Now, then we start with with an organism like man. What's the probability? How many cells does a man have, or a woman? Millions. How many different kinds of cells do they have? All kinds. We're taking now this mannatech, which is a glyconutrient, which supposedly allows cells to communicate with each other better. But the fact is, there's all kinds of cells. How do they know how to talk to one another? It is so complex that some people believe that the probability of man happening by chance only would be greater than 10 to the millionth power. Let's just take one thing. Bob had his eyes worked on a while back. What's the probability, Bob, that the eyeball with all the related parts that you can see light, which we can't even define, where you could actually see light? How many things must be concurrently present before you can see?
Wow.
Light has to be there and a bunch of other stuff. How many things have to be concurrently present before an automobile works? Can you imagine taking that large red truck of yours and you drive it up to Chesapeake and say, I dug this out of my backyard? But the fact is, that truck is trivial compared to the probability of one protein of one cell happening by chance. But look at the reason why we know that can't happen is because you've got to have all these concurrent parts that have to fit together, work together before that engine, that vehicle works. And so we know that concurrency becomes an irreducibly complex probability. It's impossible. And then we have ears. What's the difference between seeing and hearing? I mean, theoretically, what is the difference between hearing and seeing? Some loud music hurts my eyes, Bob. What is the difference? Are they both waves? Is light a wave? Or is light a particle? Yes. It has the attributes of both. Sound is a wave. How did this one cell being that started with decide, gee, I think I'll hear today. So I'm going to grow this enormously complex, ear or eyes. And by the way, every single eye that exists in any kind of animal, no matter how simple they look, it's just incredibly complex. So now then you have so what do you think the probability is when you look at 10 to the millionth power and put all the atoms of the universe over that? What do you think that 10 over the 75th over 10 to the millionth power is? Because now, let's see how smart you are. If I take 10 to the third and divide it by 10 to the fifth, what is the answer? Nope. Now think about it. I've got how many zeros on top? 3. How many zeros on bottom? Cancel out, so how many do I have left? 2 on the bottom. You simply subtract them. Over here we're adding them. So here, this is simply equal to 1 over 10 to the second. Now, if I put the total number of atoms over the probability, that's 10 to the 75th here, over 10 to the millionth power, what does that end up being as a fraction? 1 over 999,925. We already said 1 over 10 to the 50th by every secular statistician I've ever read said anything that's even close to this is impossible. Now we come down to the grand finale. If this is really true, and I really do believe that this is true, this is stuff that can be proven. This is they know that they can set up these probability scales, and they know this is true. I've even read some of the secular writers, and they understand the probability, and they say we still believe in evolution. But if this is true, then what have we done by going through all this process here?
Without change.
We've ruled out chance. That's exactly right. All right, so now then we come down. So we said, if by chance, what is the probability, right? So now then, chance is what? Okay? Is impossible, 0. Now, if chance is impossible, then what does that mean? Okay, now let's make sure. We're trying to get down to, so we started off with this argument now. If chance is impossible, then what else must be true? No God must be false. That's it. And that becomes not God is false. Now, we come to the last statement then. If not God is false, then what? God is true. Because we have to go back up here to our original syllogism, which was this: God or not God. Okay? And if not, bear with me here, if not God means that not God is false, then God must be true. And so we did this then in mathematics. This is called an indirect proof. If you've taken math courses, you understand if I have only two choices, you can assume one to be true, and when you come down and show that that's impossible, the other one must be true. Because you only got two choices. This is not a fallacious dichotomy, like many people assert. It is an irrefutable statement. There's either God or not God. If you come down to the point then where not God is absolutely categorically impossible, you must say God is true. Now, I did not say anything about what this God is. Which God is it? How many gods are there that people believe in? Oh, probably more than we can count. A Google. No, there's nothing. There's lots of gods people believe in. How do you know you're believing in the true God? Well, that becomes the next subject then. But I do think beyond a doubt, we're not talking about reasonable doubt here. We're talking about any doubt, with beyond any doubt, not God is false. And you have to conclude that God is true then. You do not know what this God is like, though, do you? And that's what we're going to do next time.